Hello all, welcome back to my channel. Okay, so in this lecture we are going to understand about serialized snapshot isolation. Okay, so before understanding serialized snapshot isolation, let's recap till now what we have understood. Okay, so till now what we have seen that either there is strong consistency but the performance is slow, or the performance is high but the conflicts are like extremely high, or maybe less, but there are conflicts basically which leads to bugs. Correct. So for example, in the two videos from now we have learned about how to serialize. So what we did, that one transaction can run at one time only, or one process can run at one time only. So we are basically not allowing other processes to run, which can make the software extremely slow. Second is two-phase commit. Okay, so in two-phase commit, what we do till now, so for example, if we have to do both of this action, we will first go here, make a lock, and then go here, make a lock. If both of them are like good to go, then we commit the message. But let's say uh, if some another process wants to read this database or something, okay, because of this lock, he can't do that. Correct. So basically, we are stopping other processes or other transactions to occur. Correct. So this makes our makes the software extremely slow. Okay. So now we are bridging this gap using SSI, which is serialized snapshot isolation. Uh, so here there won't be any conflicts, yet it will be surprisingly having good performance. So how is this happening? Okay. So first question, why was the operations extremely slow? Either we are stopping other processes to run itself, or we are grabbing locks, which is causing delay. Like other transactions cannot do anything because there is a lock. Correct. So we are not doing this lock itself in SSI. Okay. Let me give you a little bit of like history about SSI. SSI was first researched at 2008, and it was used first time in Postgres 9.1. Okay, cool. Now understand what SSI actually does. So let's say these are, so in previous lecture we have already learned about snapshot isolation. So we will continue that. Okay. So let's say at time at time 01, okay, Ashish is online. Okay. Now Ashish went and set his status as offline at time 02, but he has not committed it yet. Okay. And the thread or the transaction in which Ashish is sending himself offline is T1. Okay. At time 03, I want to add Ashish in a call. Okay, I have not committed this yet. I have checked that is Ashish online or not. I see Ashish is online because this offline thing is not yet committed. Correct. So I see Ashish is offline. So I tried now. So this is basically I'm checking. Okay, checking. Okay. At time T4, I mean time 04, thread 1, which Ashish was using for creating, making himself offline, he committed that message. Okay. So when I see that Ashish is online, but here I see that there is a transaction which is happening. It may change Ashish from online to offline. Okay. So I will track it. Okay. I will track it. So before committing, I will check is Ashish online or offline. I have seen that, oh, transaction one already made some changes. So I will abort transaction two. Okay. So this is actually what happens. So basically from this example, what I want to say is in SSI, we are using the optimistic approach. Okay. So we will make the changes. We won't commit. We will only make the changes thinking that everything will go like everything will happen perfectly. Okay. But if there is any risk, we put some tripwire kind of thing. Okay, we put some tripwire. Like here, we say that hey, there is one transaction already going on, so put a tripwire. Okay, if that require make some changes, then we abort, then we roll back. Okay, so because of this optimistic approach, SSI is like extremely fast. So here we are making the changes parallelly. Okay, but if something goes wrong, we just abort the changes, we don't commit it. Okay, so before committing, we just check if there is any tripwires. If there is any tripwire, go back. Cool. So the trade-off is basically blocking the calls or blocking the transaction versus rolling back the transaction in case of SSI. Okay. How can we check like what was the state before and what can be the state next by using epochs? Like what I have done. These are not times actually. When I said these are time T1, T2, T3, T4, actually these are not times. These are actually epochs. Okay. For each and every changes we are making, we put an epoch. So like at epoch 01, Ashish was online. At epoch 02, Ashish is making a transaction in which he is trying to make himself offline. At epoch 03, we are checking that can we add Ashish inside a call, but we have seen that there is already a transaction which is 02, okay, which is running and that has not yet committed. So we put a tripwire with respect to epoch 02. Okay, at epoch 04, Ashish committed the changes and he became offline. Now, as we know, at epoch 03, we were tracking 02 at at T2, I mean transaction T2. Okay, that's why we aborted it. So we use the thing epoch. So for every changes we make, every changes there will be a epoch. By that epoch, we will know that something has happened in past and something we have to track all those informations. Okay, so in this case, what are the trade-offs? What are the cons? So the cons is like granularity. If you track too precisely, okay, this will be an overhead to the memory. Okay, because like if you track like too many things, like 3 is also tracking 2, 4 is also tracking 2, 5 is also tracking 2, it will be like overhead on the memory. And if you track too less, okay, there can be a lots of false aborts or loss of like, yeah, you have to roll back too many times. Okay, even if it is not valid. Okay, but what are the pros? The pros are that the processes, like two processes are not blocking each other, two transactions are not blocking each other. Okay, and basically they can run asynchronously, so you can use multiple CPU threads. Correct. So these are the pros. So before like implementing SSI, what are all things you have to like take care of? That there should not be a lot of retries. There should not be a lot of aborts. Okay, the load, which is like if the granularity thing, like you should not like track too much or track too less. You have to like make exact calculations for that. Okay, the transaction should be small. This transaction was small, therefore before commit like once it committed, when I was running the transaction 2, I was able to check it. But if let's say the transaction was taking huge amount of time, the transaction 2 will also take huge amount of time because it is tracking transaction 1. Correct. So the transaction should be slow. When can we make exceptions? Let's say transaction 1 is only read kind of transaction. Okay, at that time we can say it's okay to have like a long transaction as it is only reading. Reading doesn't change the database anyway, so if next transaction is coming, then it's fine because anyway there is no like major changes. But if the transaction is transaction 1, if the transaction 1 is a right kind of changes, like in this case it was a right kind of changes, right or update, that should not be long pull. So what we have to take care of, like abort should be less. Okay, granularity, nularity, whatever the spelling is, okay, it should be managed. Okay, transaction transaction should be short, like small timed. Okay, Even if the transactions are long, only read read transactions. Okay, it can be longer. Write transaction should be always small. If it's long, then we are screwed. Okay. Now let's go to some interview scenarios. Okay, if someone asks, like, in which scenario should you use SSI versus 2PL, which is two-phase locking? Okay, so basically the answer is, if the application or the workload is read heavy, then SSI is very good. If serializability is required, then SSI is very good. If the write is taking too long, then SSI is not good. Then we should use two-phase locking. Okay, if the writes are too short, then SSI is okay. Also, we have to check, right, how many aborts are happening. If the aborts are too much, then most probably it's better to go with two-phase locking, because if like you have done 10-20 aborts, okay, then in that case, obviously your performance is getting hit, right? So if the aborts are too much, then two-phase commits is a better option. Now, how can we like check if aborts are high or low? So maybe you can decrease the hotspots, and you can actually log things and see like why the aborts are getting so high. If you just tweak few things here and there, actually in that case SSIs are like good, but mostly in wrong right kind of workloads, two-phase commit is better and SSI is bad. Okay. And second thing is, like in banking kind of system, how can you make SSI work for you? Okay. So let me just draw a picture, then continue. So let's say in this example, this is me and I'm extremely poor person, and I went to buy a bikini and a bra, okay, from bikini shop. And so I made two reads. What is my balance, which is 100? What is the bikini shop's balance, which is $2,000? Okay. Each bikini costs like $10. So before making, before like subtracting minus $10 from mine, and before adding plus $10 to this guy, we have to check that is there any other transaction running behind my transaction. It shouldn't happen, right, that I brought something of $90 $95, I have only $5, and then I am making going to buy a bikini, right? So in that case I shouldn't be able to buy a bikini. Or even I have to check like, are bikinis like present or not. So this kind of checks we have to first do. If all commits I have already done and there is no like conflicts, then I can proceed with my transaction. Okay, obviously the transaction will be two-phase commit, but yeah, I mean, before making the transaction, we shouldn't like stop our whole application. We should like, you got what I'm trying to say, right? So this can be one scenario. Thank you.